Hello students, in this video you will learn exponents. We will be learning the concept of exponents together with the questions. I hope you know the basic concept that exponents means that we are representing number in power notation or exponential form. Let me take an example, 2 raised by 4. So which means 2 is multiplied to itself 4 times like this. So instead of writing 2 4 times multiplied, we just say 2 raised by 4. It's easy to write like that. So here 2 is called the base and this 4, this is called either the power or we say index or it's an exponent of 2. Okay. Now why do we need these exponential form? One thing that if let's say you have to multiply 2 10 times, so we say 2 raised by 10, yeah, which is 2 into 2 into 2 into 2, how many times? 10 times, yeah. And if we have very big numbers, let's say 1 trillion you know is what? 10 raised to the power 12. So instead of writing 0 so many times, we just say 10 raised by 12, okay. Or you know 1 nanometer, which is 10 raised by minus 9 meter. So to avoid the mistakes of missing out the zeros, better way to represent them in the form of exponential form. Okay, now let's begin with the first question. Express the following in standard notation. Now standard notation is that we express the number in the powers of 10 and we try to not write these many zeros in the number if you have this. Okay, standard notation is also called a scientific notation. Yeah, so let's begin with first question here. So let's see how many zeros are there. 1 2 3 4 5 6. Okay, 6 zeros. But in standard form what we do is we convert this number from, let's say, between this 1 to 10. We have to make it like this. Okay, this number, I'm not talking about this whole number because it is less than 1 only, correct, but we just represent it like this one we have to convert. So 129. So now what we do is we have to move this decimal from this place to this. After this first digit, 1 is the first most significant digit, we put decimal over here. Okay, now how many places? We move to 7 places. So 10 power minus 7. When you move from left to right, this decimal place, the power is negative. First part done. Now for the second part, the decimal, where is the decimal? Decimal is at the end. For a whole number, decimal is always at the end. Now from here, because you can represent it like this, 9.0. So decimal will be moved from right to left to this after 2. Yeah, so 2.70659 into 10 raised to the power. Now when we move from right to left, it is power positive. So 5 places I have moved. This is my answer. I hope it's clear. Okay, now let's move to the next question. Write this in expanded form. Now what do you mean by expanded form? You have done expansion of numbers in first, second, third, fourth, all these grades. So we can write it as what? 7. How many digits are there? 1 2 3 4 5. Yeah, so 5 zeros. Okay, then 0, just write like that. 1, how many digits after this? 3. So 1 2 3 5. How many zeros after that? 2 60 plus 8. This is the expanded form. Okay, now but this expanded form, I'll try to write it with the powers of 10. So 7. 10 raised to the power, how many digits are zeros are there over here? 1 2 3 4 5. 0 into 10 raised to the power 4, because it is at which place? Ones, 10, 100, 1000, 10,000. So 4 zeros. 1000, 1 into 10 raised to the power 3. 500, 5 into 10 raised to the power 2. Plus 6 into 10 raised to the power 1 plus 8 into 10 raised to the power 0. Okay, why 0? Because anything power 0 is 1. That's the law of exponent. Anything power 0 is termed as 1. Okay, now here I have written this number in expanded form, the place value, you know, ones, tens, 100,000, 10,000, lakhs, and then I wrote those place values with the powers of 10. I hope it's clear, students. Now third question, let's take. You need to fill up this blank. So what is the power of 10 over here? 6 is over here. Then how many zeros? Let's count. 1 2 3 4 5 6 7 8. So the blank over here will be 8. So this can be represented as 6 into 10 raised to the power 8. I hope this part is clear. Now let's move to the fourth question. Find the value of minus 3 to the power 4. So here base is minus 3. So this base minus 3 is being multiplied how many times? 4 times. The power represent that we have to multiply it 4 times. So what is it? 3 3s are 9. 3 3s are 9 and 9 9s are 81. But negative numbers. How many negative numbers are there? Even number of negatives. So answer will be positive. Okay students, I hope this is also clear. Now let's use the law here in the fifth question. Simplify this using law. Now which law will be used over here? Here the bases are different but we see the power is common. Yeah. So we will use this law, a raised to the power n into b raised to the power n. So what do we get? A into b we do and we take the power common because the power is common in these two different bases and it's multiplication. Okay. So which law will be there? This law, and we'll write x into y into z power 3 because all these bases have same power. So it will become xyz power 3. I hope it's clear. First law we did here. Second law is this one. Okay. The law sequence I'm changing based on the question. Okay students. I'll write one more law based on this if we have this in division also. Okay. So we can write it as a by b power n. Fine. Now again this law came anything power 0. The first one that I wrote is 1. So when we simplify, what is 19 power 0? 1. What is 18 power 0? 1. Okay. Do you have to simplify further? I don't think so, but okay, let me write it. 8 square is 8 to the power 2, which is 8 into 8, 64. 5 cube is 125, but as it is 0, 1 minus 1 is 0. So your answer is 0. You don't need to simplify further. Okay. With this step also you know the answer. I hope it's clear students. Yeah. Now next question says express this using power notation. So how to do this using power notation? So my request to all students that please remember squares up till 30 for exponent chapter. Okay. And cubes up till 11 or 12. Please try to remember them because then it will be very easy for you people to do these questions. Yeah. If you don't remember, then you need to do prime factorization. Okay. So 343. The number is not an even number, won't go by 2. So it will go by 7 as I know it's a 7 cube. So 7 4s are and 7 9s are 63. Then again 7 7. So what do you get? This is 7 into 7 into 7. Okay. And 1 3 3 1. As a number represents, it will go by 11. So 1 2 1 and then again 11 11 11 1. So this is 11 into 11 into 11. But as the answer is negative, so what will I do? I'll just take 7 with this and 11 into 11 into 11 because the answer is coming negative. So what is it? Minus 7 cube by 11 cube, or I can say minus 7 by 11 cube. I hope it's clear students. Okay. This is what we have done. We represented it using power notation. Fine. Because if I take 3 negatives, it will make 1 negative. Okay. Now comes the next question. Use law of exponents to simplify this. So it's a very important question. So there are different ways of solving these type of questions. It's up to you students, whatever you want is easier for you, try that. I'll try to explain the way I explain it to my students. So whenever you have numbers like this, okay, numerator, denominator, the law that we will use over here is a raised per n into b raised to power n. No, sorry, not this b. It's the same base, a raised per n into a raised per m. When base same, product and powers different, we add the powers. Okay. When again base same, but there is a division like this. Yeah, the bases are being divided, powers is different. Then we subtract the powers. Okay. Fine. These two laws are the ones that we are going to use in this question. Also, whenever you have numbers, composite numbers, 25, 10, 6, 3, 5, they are prime numbers, don't touch them. But whenever you have composite numbers, just split them in their prime factors. Also, one more law is over here. What I'll say, use it. Let's say we have given it earlier also, a raised per n into b raised per n. Okay, so we do a into b power n. So we can reverse it also. Okay, we can do it in reverse order also. For example, 10. 10 power 5. 10 is what? 2 into 5. Okay. So this is what I'm doing. I'm just splitting it up into its factors, 2 into 5, and then I can give it as 2 raised per 5, 5 raised per 5. Okay. Now, let's begin with this same thing. So 3 raised per 5 as it is, all right. 10 I'll split as 2 raised per 5 and 5 raised per 5. I explained it here. 25 you know is 5 raised per 2, a raised per 9 as it is, and here what I have, 5 raised per 7, 6. 6 again I'll split. 6 will be what? 2 raised per 5 and 3 raised per 5 into a raised per 4. Okay students, I hope it's clear. Now what you can do over here is either you minus or you cancel it out. Okay, it's your choice. See, we have two common things over here. 2 raised per 5, 2 raised per 5 cancels out. 3 raised per 5, 3 raised per 5 cancels out. Done. Now what is left? Only 5, 5, 5, 2, a9, 5, 7, a4. So let's do, base is same. So what will I do? I'll just add these two powers. In the numerator first I'll do, yeah. I'll write it like this and this, a raised per 4. Now what is left? 5, 7 into a9 by 5, 7 into a4. So you cancel it out. Now a, base same both, and powers are different, division it is there, so I'll just subtract it. So a raised per 5 is your answer. I hope it's clear students. Okay, it's your choice. You could have simplified it another way. Just say you just add directly and minus it. Here in this step also you could have done. Just to explain you have done separate steps. Okay students. Now let's move to the next question. Same way I'll proceed. What I'll do is, I will not touch the prime numbers, but 16 I can say is 2 raised per 4. And 64 is what? It's 4 cube basically. So 4 cube means it's 2 raised to the power what? 6. 64 is 2 raised per 6. Now let's talk about the same basis in the numerator. So plus 4, these two, 2, 5 plus 4, 3 raised per 4 by 2 raised per 6 into 3 raised per 2. Okay, I just reposition. So now it is 2 raised per 9 into 3 power 4 by 2 raised per 6 into 3 square. Now you can subtract the powers because the bases are same. You take the respective bases only which are same, and 3, 4 minus 2. So what you will get? 2 raised per 3 into 3 raised per 2. So as the powers are smaller, we can simplify it. It's 8 into 9, which is how much? 72. I hope it's clear students. Okay, so I have used the laws only over here to simplify it. You can do it in your way also. Some students will do that. They will cancel 16 and 64. 4s are correct. It's your wish. You can try that way also. Okay, and do it. I've just used laws here. Now question number 9, a part. You have 2 raised per 3 into x is 4x. So you have to find the value of x. So in all these parts we have to find the value of x. So how do we do is, we just try to make the bases on both the sides equal. Okay, this is LHS, RHS. So in LHS and RHS, what do? We try to make bases same on both sides. Okay, so when we do that, as the base is same on both the sides, what we do? We can equate powers. Then what do? We equate the powers, because if base is same both dono side pe, to unke powers will be same. Okay, so let's do that. So what law I'll use? I'll use this law over here. If it is like this, so you multiply the powers. Okay, so 2 raised per 3 into x is 4. Now 4 you can represent in terms of 2 power 2 this. Okay, so what you will get? 2 raised per 3x, 3 into x is 3x, and 2 into 6 is 12. Okay, now base is same both the sides. On equating powers on both sides, what we will get? 3x is 12. If 3x is 12, from here x will be 12 by 3, which is 4. Clear? We are done with this. Now let's move to the next question, B part. Same thing we have to do. We will do what? We will equate the powers. First we will make the bases same. So first LHS 5x into 25. 25 is 5 raised per 2. So we can write it as this, and 5 raised per 14. So 5 raised to power x into 5 raised to the power 2 into 3, 6. 5 raised per 14. As the base is same, I will add the powers here. Okay, now I'll again equate powers on both the sides. So x plus 6 is 14. So x will be 14 minus 6 transpositioning. So it will be x is 8. Okay students, I hope it's clear. Now let's move to the next question. Now next question, there is a division part over here. So let's do the same thing. So 5 power 2x plus 1 divide by 25. I'll write like that. Okay. Then 5 power 2x plus 1. Either you can do take it here. It's your choice. Or you use it over here. I'll do both the ways. So it will become 5 raised per 2 here and 5 raised per cube here. Okay. Next step. Now what do? Division में base same. So we subtract the powers. Okay. So 5 raised per 2x minus 1, 5 raised per 3. Now equate the powers again. So 2x minus 1 is 3. So 2x is, you take it here, 3 plus 1. So 2x will be 4. So what will I get? X as 2. Okay. Or I'll try this other way also. What I will do is, I will take this 25 over here. So it will be 25 into 125. But do not multiply it, please students. Don't increase your work. Yeah. What you do is, it is 5 raised per 2, it is 5 raised per 3. Fine. Add the powers. What will it become? It will become 5 raised per 5 and 5 raised per 2x plus 1. So again equating the powers, 2x plus 1 is 5. So 2x is 5 minus 1, 4. So x becomes again 4 by 2, which is 2. Okay. I hope it's clear students. So please try to understand by solving these questions. Whenever you see math videos where there are problems which are solved, so request to you that don't just watch it, you will have to solve it together. Okay. Or you pause the video, you try on your own if you get the right answer and practice it. Okay. Maths is all about practice and try to understand what the question is saying. Fine students. Thank you for watching the video. Please, if you like it, share it with your friends. Like it also, and do send me comments if you have any other doubts. Bye students.